Welcome back to the Revit for MEP Modular Training Series. For those who missed Module 10 where I introduced myself, my name is Ryan and I took over from Derek to do Modules 10 and 11. Derek will continue from Module 12 to 14 and my other colleague Jane will do Modules 15 to 17 and Derek will then do the final lap, that is, Modules 18 to 20. Over to you, Jane.
Thanks, Ryan. Hello, everyone. My name is Jane. I'll take you through Module 15, Spaces, Zones, Areas and Volumes, Module 16, 2D Drafting and Annotation, and Module 17, Sheet Compilation and Publication. I hope you'll find it very informative and insightful. Derek wants to make some announcement.
I'd like to announce that we've decided to include a capstone project which follow after Module 19. According to the course agenda, we're supposed to start from Module 0 to Module 19. However, we've realized that it'll be important to add Module 20 at the end, which is a capstone project for delegates to test their skills and knowledge. We'll upload an architectural model and 2 DHVAC drawings for delegates to convert into 3D multiple story project. We'll also share access to our reusable family library for you to download to assist in finishing the project with less hustle. We can make it an interactive exercise with those who'll get stuck and seek assistance. We'll discuss this project thoroughly after Module 19. Thank you.
Thank you, Derek. You've made it very clear and I trust everybody understand. Okay, now, back to Module 11. In this module, Module 11, Geometry Formation and In-Place Families, we explore the fundamental building blocks of Revit's 3D modeling engine. This is an interactive and highly practical module designed to give you a deep understanding of how geometric forms are created, how they behave, and why Revit expects elements to be built in certain ways. In this session, we focus on the different types of geometric forms available in Revit, the foundational shapes that lie behind every hosted family, every system component, and every custom object you will ever model. The purpose of this module is to understand how these shapes work, why they behave the way they do, and how to apply them when creating project-specific geometry, especially when standard family templates are not sufficient. We will be creating forms in the in-place family environment. This is the tool you use when you need one-off, unique components built directly in your project, things like decorative elements, irregular shapes, bespoke casings, architectural features, or one-time elements that don't need to be part of a reusable family library. During this module, we will explore the 6 core modeling tools that form the backbone of all Revit geometry creation. 1. Extrusion. Extrusions are the simplest form, a 2D shape pulled up to create height. Think of items like shafts, beams, blocks, or slabs. 2. Blend. A blend transitions from one closed shape to another. This is ideal for tapered transitions or components where the profile changes along the height. 3. Revolve. Revolve creates a 3D form by spinning a profile around an axis. This is used for round elements, columns, knobs, housings, casings, and circular profiles. 4. Sweep. A sweep extrudes a profile along a path. The path may be straight, curved, or multi-segmented, making this tool perfect for ducts, pipes, moldings, handrails, or cable containment. 5. Swept blend. Swept blend combines the ideas of a sweep and a blend, taking 2 different profiles and connecting them along a defined path. This allows you to create highly adaptive, flowing shapes. 6. Void forms. Every form we create can also exist in reverse, as a void. Voids cut into solids, creating holes, recesses, notches, channels, and penetrations. Understanding the relationship between solid and void geometry is essential for precise modeling and clean geometry control. Cutting and joining geometry. Finally, we explore how solids and voids interact, how to cut solids with voids, how to join solids together, and how the order of operations affects the outcome. These behaviors form the basis of all 3D detailing and help ensure geometry remains clean, editable, and efficient. By the end of this module, you will have a strong understanding of each of these form types, not only how to create them, but how they can be combined, edited, and managed in the in-place family environment. This foundational knowledge prepares you for more advanced modeling challenges and gives you the skills to produce custom, project-specific geometry whenever necessary. In this hands-on exercise, we'll create all of Revit's fundamental forms inside an in-place family: extrusion, blend, revolve, sweep, swept blend, plus voids, and we'll finish by cutting and joining solids. Follow me step by step in the same file, and I'll call out view changes as we go. Part A. Extrusion, Steps 1 to 22. Step 1 to 2. Start and open the working view. Create a new Revit project, then open floor plans to level 0. If your template names levels differently, that's okay. Just stay on the same level when I call it out, unless I tell you otherwise. Step 3 to 5. Enter the in-place environment and pick category, go to Architecture arrow component and choose Model in Place. In Family category and Parameters, set Filter List equals Mechanical, then choose Generic Models and press OK. Give the family a unique name and confirm. Step 6 to 7. Create the extrusion profile. From Forms, click Extrusion. Use the Draw tools to sketch a closed-loop profile. The shape is not important here. Keep it simple. Multiple boundaries are allowed. You can also nest a boundary inside another to create a cutout, as long as boundaries don't touch. Step 8 to 10. Give it height and finish in Properties, Set Extrusion. Start and extrusion end to define the height. Click Finish Extrusion, green tick. Then open a 3D view to review the solid. Step 11 to 13. Edit the profile to make a through hole. Back in Plan, select the shape and click Edit Extrusion. Add a circle entirely within the boundary to define a void in the middle, then finish and review in 3D. Step 14 to 15. Create overlapping cylinders. Start extrusion again and draw a circle that overlaps the edge of the main shape, then finish extrusion. Step 16 to 18. Duplicate and convert to void. Duplicate that cylinder so both copies overlap the main shape. In 3D, select one cylinder and drag its base up so it starts partway up the main solid. In its properties, switch solid/void equals void. Step 19 to 21. Cut and join geometry. Use Cut, Geometry panel. Select the void, then the main solid to punch the hole exactly where you want it. Now select the other cylinder, raise its top above the main shape, and click. Join to merge it graphically with the main solid. This prevents double-counted volume and creates clean edges at the intersection. Step 22. Exit in place. Click Finish Model to return to the project environment. All pieces now behave as a single object, but remain editable solids/voids. Part B. Blend. Steps 23 to 31. Step 23 to 25. Reset and re-enter. In place, on level 0, either delete your previous form or move it aside. Go to Component to Model. In place, pick Generic Models, accept the suggested name, and continue. Step 26 to 28. Base and top profiles. Choose Blend. Sketch a closed loop for the base profile. Stay in this view and click Edit Top to sketch a second closed loop for the top. Tip: matching the number of vertices in both profiles, for example, a square to a 4-arc circle, creates smoother transitions. Step 29 to 31. Height, Material, Finish. In Properties, set first end and second end to control height and offset, and assign material if needed. Click Finish Blend, then review in 3D. You can always fine-tune height later in elevation or 3D. Part C. Revolve, steps 32 to 39. Step 32 to 35. Setup. Back on level 0, remove or move the last form. Create a new model. In place to generic models and accept the name, choose Revolve. Step 36 to 37. Boundary and axis. From Draw, pick boundary line and sketch half of the cross-section as a closed loop. Then choose Axis Line and draw the axis you'll spin around. The axis length doesn't matter. It must be planar and must not cut through the profile. Step 38 to 39. Finish and review. Click Finish Revolve, then open 3D to review the turned form. Part D. Sweep. Steps 40 to 49. Step 40 to 43. Enter and choose Tool. On level 0, clear space is needed, start model. In place to generic models, accept the name and choose Sweep. Step 44 to 45. Path, 2D or 3D. Click Sketch Path and use Spline or any draw tool to create the path. A sweep path may be open or closed. If you want a 3D path, instead use Pick Path to select edges of existing geometry. Step 46 to 47. Profile, perpendicular view. Click Edit Profile and draw a closed loop for the profile. You'll need to switch to a perpendicular view to the path at the edit point. Revit requires the profile plane to be perpendicular to the path. When done, finish Edit mode. Step 48 to 49, finish and review, click Finish Sweep, then Finish Model to exit in place and review in 3D. Part E. Swept Blend. Steps 50 to 65. Step 50 to 53. Start and choose Tool. On level 0, clear or move previous forms. Start Model. In place to generic models, accept the name and pick Swept Blend. Step 54 to 55. Path, click Sketch. Path and use Start to End to Radius Arc, or any draw method, to define the path. Like Sweep, the path may be open or closed. Finish the path with the green tick. Step 56 to 60. Profile 1, Start. Open Elevations, South, any perpendicular view works. Select Profile 1 to edit profile, and draw a closed loop at the start of the path. For the example, sketch a rectangle. Finish the profile. Step 61 to 62. Profile 2. End. Repeat for Profile 2 to edit profile at the end of the path, drawing a triangle this time. Finish the profile. Step 63 to 65. Complete the form and exit. Click Finish Swept Blend, then Finish Model to exit the In-Place editor. Open the 3D view and review the result. You've just connected two different profiles along a single path to create a smooth transition. That completes the full Module 11 exercise. Extrusion, Blend, Revolve, Sweep, Swept Blend, plus Voids, Cut, and Join in the In-Place Family Editor. In the next module, we'll build on these fundamentals to tackle more advanced geometry and detailing.